Glad to see everybody coming back in for the final session. I'm your moderator for this last session. My name is Glenn Schubert. I'm a forensic scientist with the Illinois State Police at the Southern Illinois Forensic Science Center in Carbondale, Illinois. Our next speaker is Tom Geddes. He graduated from the University of Durham in July 2004 with a master's degree and honors in chemistry. He's worked as a forensic scientist in the Marks and Trace Evidence team at LGC Forensics in the United Kingdom. Tom is going to be speaking about a case of the interpretation of glass evidence within a select population, an incident of assault with a broken bottle in a prison. Tom?
Hello everybody, I'm Tom. I'm part of the Marks and Trace team at the LGC Forensics Laboratory in the United Kingdom. That's where I mostly work with glass evidence and footwear evidence, amongst a few other things. Since the topic of this year's symposium is the interpretation of trace evidence, and kind of to follow on from what's been said earlier, I'd like to tell you a little bit about a case I worked on a few years ago, which caused me some real difficulty at the interpretational stage. The incident itself took place in a closed environment inside a prison, and there are differences between the prison environment and the day-to-day environment, and this gave me some real head-scratching as I was trying to work out what it all meant. So what I'd like to do is just tell you a little bit about the case circumstances, and then about my findings, and then I'd like to give you a really brief overview of the Bayesian interpretation model that we use within our laboratory. And then I'd like to show you how the unusual nature of this case made it really difficult to assess this. So, in a prison in the United Kingdom, one of the inmates was struck about the head with a glass bottle, which smashed. And another of the inmates was suspected of being involved with the incident. I was asked to examine the clothing from the suspect for the presence of glass fragments and to compare any found to the control glass sample that was found on the shower room floor. The control glass sample itself was a bottle of Encona hot pepper sauce, which I'm told is a commonly available brand in most United Kingdom supermarkets. So, unfortunately, the lower clothing of the suspect wasn't available, but I did have a t-shirt and a cardigan to examine. And no glass fragments were found on the t-shirt, and on the cardigan, a single glass fragment was recovered. This glass fragment was 0.2 millimeters across, and when it was analyzed using the GRIM-3 instrument for refractive index, it was found to match the control glass sample. The glass fragment was also found to match the control glass sample in elemental analysis using the scanning electron microscope microprobe analysis. So, with the analytical work complete, I was left with the task of working out what on earth it all meant. Well, like a lot of laboratories in Europe, in Britain, and a lot of the rest of the world, we use a Bayesian interpretation model. And without going into too much detail, one of the real key features of this method is the consideration of two opposing propositions. So, for example, the glass fragment originated from the broken bottle, or the glass fragment did not originate from the broken bottle, it originated from some other unrelated source. Now, for any given case, there's a whole range of different propositions you could possibly consider, but on the whole, they can be divided into three different categories: source level, activity level, and offense level. This proposition over here is a source level proposition, in that it's considering whether the glass fragment came from the bottle or whether it didn't. There's no consideration about how this glass fragment was acquired, and the actual specific numbers of matching fragments don't make any difference. It's the fact you found any at all. This proposition is an activity level proposition. Mr. X smashed the bottle, Mr. X did not smash the bottle. What you're doing at activity level is using your expert knowledge on how glass fragments are acquired, how they're retained, and how many glass fragments you'd expect to find on a member of the population to make some kind of assertion about how the glass fragments were acquired. The offense level, in this case, would be that Mr. X struck Mr. Y with the glass bottle. We don't go anywhere near this very often because, on the whole, this is the role of the jury to decide, and so I'm going to steer well clear of that. But no matter which set of propositions you choose, you then have to go on to consider a likelihood ratio. Simply put, when you consider a likelihood ratio, you consider the probability of the evidence if the first proposition is true, and then consider the probability of the evidence if the second proposition is true, and divide one by the other. If the likelihood ratio is greater than 1, then it supports the first proposition. If the likelihood ratio is less than 1, then it supports the second proposition. And if the likelihood ratio is 1, then the evidence is equally likely if either proposition is true, and so the findings are inconclusive. To allow us to explain this to a court, or in a statement, or to the police, we assign a verbal scale. You'll see that this is a logarithmic scale, such that each step along the scale offers 10 times more support than the previous. But how do we actually calculate these likelihood ratios? Well, fortunately, general equations have been proposed for calculating the likelihood ratio at both source and activity level. Now, normally for any given case, you would probably only consider it at source or at activity. But given this case, there were arguments to deal with it at both levels. What I'd like to do is show you the equations for source and activity, and show you the variables that come into play. And then I'd like to tell you a little bit about how my unique set of circumstances made assessing each of these variables really difficult. So if I start with source level, this is the general equation that we usually use. As I was saying earlier, all that matters is that you found matching glass. So the key factor here is the frequency of occurrence. How common is this particular type of glass? And this is represented by F. G is the number of groups that you've found on someone's clothing. This whole term, G minus 1 factorial divided by G factorial, takes into account the fact that if you find lots of groups of glass from different sources, it increases the chance of there being a random coincidental match, and this obviously affects your evidential strength. Fortunately, in this case, G is equal to 1, and so this whole term just drops out. But how would I assess the frequency of occurrence? In our day-to-day casework, we use a database of controlled glass samples that have been submitted by the police for our analysis. The difficulty is always with databases is knowing what they mean and whether they really are kind of suitable for what you're making inferences about. Our database is very heavily skewed towards window glass because that is the majority of the work that the police ask us to do. Given the normal casework, we're often able to identify glass fragments as having an original surface or some feature that would allow us to categorize them as being window glass, and so it's not such a problem. But in this circumstance, where in a prison it's highly unlikely there's going to be a lot of smashed windows, it seems very unlikely that our database is really going to fit. So I was left with the problem of kind of assessing what types of glass were available in this prison. And I contacted the police and asked them to see if they could help me. And the best they could provide me was a prison shop inventory. These are all the items that the prisoners were allowed to buy with their money. And there's quite a few surprising items on there. Amongst them, there are a number of glass jarred and bottled items, including our offending bottle of hot pepper sauce. So the first thing I was really trying to find out is how many relative units of these sort of things were sold, and usefully to who. Unfortunately, no such information on how many of these units had been sold had been kept. But even then, it would only be half the picture, because although now I know there are glass items in the prison, it's likely there are other glass items as well, maybe items used in the kitchen or in containerware and cookeryware. Although, given the refractive index and the elemental composition, a number of types of glass may be able to be excluded. So this is by no means a straightforward value to approximate. If I now kind of skip across to thinking about activity level propositions, this is the set of propositions I would be thinking about if I was treating this case at activity level. That is, Mr. X was in close proximity when the bottle smashed, or Mr. X was not in close proximity when the bottle smashed. Now, This is not strictly an activity level proposition. You could have maybe, as I said earlier, said that Mr. X smashed the bottle or Mr. X did not smash the bottle. And the reason I chose to steer clear of this is because there's little data available regarding how far glass fragments actually shatter from a broken bottle. I'm aware of a piece of research that was done in our laboratory that found glass fragments up to 1.2 meters away from a bottle being broken. But the researchers had clearly set out to only collect glass from up to 1.2 meters. And so I don't really know whether they'd have found more if they'd have actually looked further afield. And given this kind of unknown factor, I thought it was more safe to consider that Mr. X was in close proximity, as he may have been nearby when someone else broke the bottle, or when the bottle broke by some other means. So this is one form of the equation we use for calculating activity level propositions. This is only a stripped down version of this equation, as the first equation that was proposed has values for if you have more than one matching control sample. And to keep things simple, I've just stripped it down for only one matching control glass sample. You can see that the frequency of occurrence is still a factor, as is this number of groups and the coincidental match terms. But there are now some further variables that we have to take into account. The first ones I'm going to talk about are the P and the S values. The P and the S values tell us about what would happen if we took someone from a population and searched their clothing for glass. What would we expect to find? How many glass fragments would we find? How many groups would they form? And how large would these groups be? So P is the probability of finding a number of groups, G, and S is the probability of finding a group of this particular size. When we assess this, when we use this sort of data, what we do is we consider clothing population surveys that have been previously performed. It's generally recommended that any country or state using this sort of approach generate their own set of data so that they know it's suitable for their area. In the United Kingdom, there are really two pertinent papers that we really take into account. The first is the McQuillan and Edgar survey, which was performed in Northern Ireland and related to people who essentially were selected at random from a population of people who had no involvement in property crime. The second survey, the Lambert, Satterthwaite and Harrison survey, was performed at the Forensic Science Service laboratory and was a survey of people suspected of involvement in property crime. Without making any contentious comments about innocence or guilt, it was found that there were more groups of glass were found on the clothing of people suspected of property crime than people just selected at random from the population. But it was found for both surveys, it was uncommon to find large groups from the same source. And it was generally established that anything of 3 glass fragments or more was an unusual finding. The difficulty I have is that in my case, I only had a single glass fragment, so this is not a particularly large group for an outside world population. But which of these surveys, if any, is really suitable for the prison environment? Well, given the amount of glass that was found in the Lambert, Satterthwaite and Harrison survey, I think it would be inappropriate to use this survey. So I was left comparing a prison environment to the McQuillan and Edgar survey, or the survey of people going around their day-to-day business in their everyday lives. And it's very difficult to, without having ever lived in a prison, to really know about how these two populations compare. My intuition on this was that given the nature of the prison environment, any broken glass would have been swept up and cleaned away very promptly, making contact with broken glass reasonably uncommon. So it may be the same as a outside world, or it may actually be a little bit less. But actually quantizing this is really quite difficult. Another thing that occurred to me when I was trying to assess this was, were there any other factors in the prison life that I hadn't taken into account that might affect this? And one such idea was whether there was an enforced laundry regime or something like that, where clothing was collected up and washed regularly for hygiene purposes, because this would mean that clothing were clean and it was less likely to even find glass fragments and would increase the significance of finding a glass fragment. So I contacted the police and found out that this wasn't actually the case and that I didn't have to take this into account. if I come back to this equation now, the final variable I'd like to tell you about is the frequency of transfer, persistence, and recovery of the glass fragments. In this case, what it means is it's the probability of finding this number of glass fragments, them being retained and then being found in the laboratory if Mr. X was indeed in close proximity when this bottle broke. When we assess this, this data, we tend to consider glass breaking experiments. The difficulty we have is that although there's a lot of data relating to window breaking, there's a lot less relating to bottle breaking that I was able to find. I've managed to find a piece of preliminary research which should be taken with a slight pinch of salt as it's yet to be peer-reviewed, but they broke a bottle and seized the clothing of the person breaking the bottle immediately. And on the upper clothing, they were finding in the order of around 100 glass fragments, which to me sounds like quite a lot. However, they were breaking a 330 milliliter bottle, which is a beer bottle. My bottle that was involved in this case was a 142 milliliter sauce bottle, and the masses were significantly different. So there was actually, I would expect quite a lot fewer glass fragments to be created during this process. But even then, my finding doesn't seem an awful lot on the face of things until we consider the persistence of the glass fragments as well, and how many would have been shed in the period between the incident and the clothing being seized. Well, the retention of the glass fragments on clothing depends on a number of factors. It depends on the activity of the wearer, which I tried to see if there was any information about that, and I wasn't able to find any. It also depends on the retentive properties of the garment. I examined the garment and said it had a moderate retentive nature. So that's really to say that it was neither particularly woolly or fleecy that would cause it to retain glass fragments for a very long time, but it was not particularly smooth either that would cause it to shed glass fragments almost immediately. It also depends on the time interval between the incident and the item being seized. And this time interval was 2.5 hours. We know that for window glass, the majority of glass fragments are shed within the first few hours of normal wear. And this would suggest that even if 100 glass fragments were acquired initially, a very large number of these would have been shed. I'm also not aware of any data relating to how long glass fragments are retained for bottles as opposed to windows. And I would suppose that if the mechanism was significantly different, we may find that the glass fragments from a bottle may actually be retained for a different amount of time than you might expect for breaking a window. But if we think that maybe the majority of the glass fragments would have been shed, then actually finding a single glass fragment, although it doesn't seem like a lot, probably isn't that far away from our expectation. So in my opinion, a probability for the t-value of 0.2 or 0.3 may actually be reasonably safe. So these are all the sort of things that I was taking into account when I was trying to make sense of all of this. So what did I do? Well, I decided to deal with the case at source level. The reason for this is that it's ideal to use source level when you don't know how the glass fragments were acquired. I know I said earlier that you can't tell the difference between glass fragments being in close proximity to the bottle breaking or indeed breaking it, but it's not really as simple as that, as the glass fragment may have been acquired by secondary or tertiary transfer, by contact with a surface or a garment of clothing or an item that was contaminated with glass. Surveys and research that's been done into this area has shown that glass fragments can be transferred this way, although generally not large groups. But it's worth bearing in mind I didn't have a particularly large group on my clothing, and given the enclosed environment and the kind of communal facilities in the prison, I really couldn't exclude that secondary or tertiary transfer may have been an option. And so I thought source level was most applicable. I was still left with the difficulty of coming up with an approximation for the frequency of occurrence, which is what I needed to assess this. I didn't want to risk over or underestimating this value because it may make a large difference to the likelihood ratio. And given that I had no database to use to assess the frequency of this glass, and insufficient resources to actually go to a prison and start finding out what other bottles were in there, I was left a bit stuck. But given that I knew that there were other glass items in the prison, it's very likely that the frequency of occurrence of the bottle must have been less than 1. And if the frequency of occurrence of the bottle must have been less than 1, then the likelihood ratio is likely to have been greater than 1. What I can't say is how much greater than 1. So in the end, I concluded that, in my opinion, my findings provide some support for the proposition that the glass fragments originated from the broken bottle. However, I'm unable to quantify my findings. By no means do I propose this as the correct way of going about this, answering this question. After writing this conclusion, I also added a list of why I wasn't able to quantify these findings to explain it, what normally I would try and assign as strength. So I would be interested to know what people think about this. I know that within our laboratory, it caused a great deal of debate on how to tackle it. And whenever I spoke to people, they seemed to have a different idea or a different consideration that I hadn't thought of. And many of them I've presented today. So what have I learned from this? Well, the good people of Encona hot pepper sauce have ensured me that there's now a squeezy plastic bottle available. And that would have saved me an awful lot of trouble in the long run. What I'd like you to take away from this really is that Bayes is a useful tool for assessing glass cases and forensic cases in general. But like all tools, it's only as useful as the way we apply them. If you get very familiar with the method or very unfamiliar with the method, it's very easy to get into the routine of just plugging numbers into equations without really thinking about the data you're using. My case is a slightly dramatic example because the prison environment is a bit of a mystery as compared to the outside world, at least for me. And so the differences are obvious. But the truth of the matter is that most glass cases and trace cases have some unusual facet or some unusual aspect that make them different. And so it's just worth thinking about when you're using a mechanism like this to think, is the data I'm using suitable for my unique set of circumstances? Before I close, I'd just like to thank a couple of people. I'd like to thank a lady called Tina Lovelock, who helped me a lot with the statistical side of this. I'd also like to thank a lady called Rachel Hewitson, who found the glass fragments in the first place, and I cursed her every day ever since. And I'd also like to thank the majority of the LGC Forensics Marks and Trace team, who contributed with their bits of input, all except one individual who, fortunately will go unnamed, who suggested, and his only useful suggestion, was that this presentation be called source level for a source bottle. So thank you very much for listening. Thank you.